Okay, so in this video we are going to talk about permutations and combinations, and we will solve some problems from Hall and Knight higher algebra. Before we actually delve into what the problems are going to be, we should first be clear about what do we mean by permutation and what do we mean by combination. So let us consider that we have these 5 letters A, E, I, O and U, and we want to arrange out of these 5 letters, we want to arrange 2 of them at a time. So permutation is about arrangement. Okay, so permutation is about arrangement, and in this case the order is important. Okay, so we have to distinguish between order. Okay, so let us try to arrange 2 of these letters out of these 5 letters. So these are the possible combination. We can have AE, AI, AO and AU. We can also have EA. So you can see that this is AE and this is EA. This is a different order, and these 2 are different things in permutation. So we are right now listing out arrangements. So AE would be different than EA. So you have EA, EI, EO, EU. Then we could have IA, IE, IO, IU. Could also have OA, OE, OI and OU, and last row would be UA, UE, UI and UO. So you can see that there are total of 20 different arrangements. Okay, but what do we mean by combination? When we talk about combination, we are only talking about selections, right? So combinations is about selection. In this case, if we have selected AE, then EA is not a different selection, it's the same selection. Similarly, if we have selected AI, then IA is also the same selection. So this is about selections, and in this case order is not considered. Okay, so let us talk about combination of 2 characters out of these 5 characters. So we could have AE, AI, AO and AU. Now next we can have EA, but AE is already considered, so we will not consider EA, but we will consider EI, EO and EU. IA has already been considered over here, so we will only talk about IO and IU, O, U, and I think that's it. So we have only 10 different combinations. Okay, I hope now the difference between permutations and combinations is clear. So now what we are going to do is we are going to derive some mathematical formulas as to how to do these kinds of problems. Okay, now look at this statement. It says that if one task can be performed in m ways, and if we have performed that task in any one of those m ways, and the second task can be performed in n ways, then both tasks can be performed in m times n ways. So this is simply a multiplicative law of permutation. What it says is, suppose we have some task which we can do it in m different ways. So let us say that this is task 1. So we can do it in m different ways. Okay, we can list down the ways we can do it. Now for any of these m ways, suppose we have done the task number 1 in any of these m ways, for each of these m ways there will be n ways of doing the second task, right? So we can have 1, 2, n ways of doing the second task. So this is the first way of doing the first task, and for any of, if we have done the first task in the first way, then we can do the second task in n ways. Similarly, if we do the first task in the second way, we will again have n ways of doing the second task, and this will go all the way up till n. So you can see that this is simply how many ways you can find. For each of the tasks we have n ways. So for m tasks it will be simply m times n ways, right? And now we will consider a formula for, so let us say this is formula number 1. It talks about permutations or arrangements, whichever word you find it easier to remember, permutations of n dissimilar things. Okay, this is very important to remember. All things are different, they are not similar. N dissimilar things taken r at a time. Okay, and we have already done this before. So we had, as an example, we have A, E, I, O, U. These are 5 dissimilar things, and we wanted to arrange it in groups of 2. So we were taking 2 at a time. Okay, so R is equal to 2. R is equal to 2 at a time, right? So n is equal to 5 and r is equal to 2. So what will be the formula for this one? We know that we have to arrange in groups of r, right? So let us say there are r blank spaces over here. Okay, so there are r blank spaces over here. Now for the first blank space, we can take any of the n things here, right? So we can fill the first place in n number of ways. What about the second place? Second place we can fill in n minus 1 number of ways, because we have already filled the first place with 1, so there will be only n minus 1 remaining. What about the third place? It will be only filled in with n minus 2 options, and so on. The rth place, the last place, will be filled in by n minus r plus 1 number of ways, and this is what we call as, we can write it in a short form as NPR. Okay, so NPR is equal to n times n minus 1 times n minus 2 times n minus 3 all the way up to n minus r plus 1. So there will be r number of terms over here. So in our example it was 5p2, which will be simply 5 times 4 is equal to 20, and we saw that there were 20 ways in which you could do this arrangement, right? Now let us look at this formula carefully. We know that we can write this as n minus 1, n minus 2 n minus r plus 1, and if I multiply this by n minus r factorial and I divide this also by n minus r factorial, now the numerator is simply n factorial, right, because it is from n to all the way up to 1. So this numerator becomes n factorial divided by n minus r factorial. So this is what is NPR. So this is the first formula that we have derived, that if we want to arrange n dissimilar things taken r at a time, then all we have to do is we have to calculate n permutation of r things taken at a time, and this value will be equal to, either you can write it n times n minus 1 all the way up to r terms, or you can also write it as n factorial divided by n minus r factorial. Okay, and what is the definition of n factorial? I think we all know what is n factorial. For any whole number, n factorial is defined by n times n minus 1. So let me write it. N factorial is nothing but n times n minus 1 all the way up to 1. So 5 factorial would be equal to 5 times 4 times 3 times 2 times 1, which is going to be 120, right? So over here we did 5p2, which was 5 times 4. We had done it like this, or we could have also done it like 5p2 could have been written as 5 factorial divided by 5 minus 2 factorial, which is going to be 3 factorial, which we can write as 5 times 4 times 3 factorial. This is the numerator, divided by 3 factorial, and you see we again get 20. Okay, now once we have derived the formula for permutation of n dissimilar things taken r at a time, now we will simply consider what is permutation of n dissimilar things taken all at a time. So that would be simply what? That would simply be n p n, which we can write as n times n minus 1 times n minus 2 times all the way up to n minus n plus 1, because r is equal to n, right? So you see that this cancels, and this is simply n times n minus 1 times n minus 2 times all the way to 1, and this value is simply n factorial. But we also know that npn could have been written as, we also know that npn could have been written as n factorial divided by n minus n factorial. Remember, npr is n factorial divided by n minus r factorial. So npn would be n factorial divided by n minus n factorial. So this means that this value should be equal to n factorial divided by 0 factorial. And what is this value equal to? From here, this value is equal to n factorial. So what should be the value of 0 factorial? It means that 0 factorial should be equal to 1. Okay, so remember this, that 0 factorial is always equal to 1. Now once we have derived the formula for permutation, let us also think about combination. Okay, so let us talk about combination of n dissimilar things taken r at a time, right? So again we have the notation, we call it as n CR. Now to derive this formula is actually much simpler. We know that, let us say that there are R number of places here. Okay, so this is R number of places. Now if we consider orders as different, if we consider orders just like in permutation, we know that these are number of things. So this is actually 1, 2 all the way to R. So these are blanks, these are spaces in itself can be arranged in how many ways? It should be R factorial, right? So for any of the combinations, suppose we have selected R number of things over here out of n objects. If we multiply that by R factorial, we simply get the number of different arrangements, right? As an example, consider when we were looking at the vowels example, we know that A and E can be selected, but this is only one selection. For this one selection or combination, we had two permutations. One was AE and one was E times A, because these two can be arranged in factorial two number of ways. So what we know is, if we multiply NCR times R factorial, we actually get NPR, right? So what should be the value of NCR? NCR simply should be NPR divided by R factorial. And what is NPR? NPR is factorial n divided by factorial n minus R. So NCR will be factorial n divided by factorial n minus R divided by factorial R. And we get this formula for the combinations. Okay, so how many ways we can find the combination of two objects out of 5 vowels? So we have A, E, I, O and U. Now we want to find out 5C2. This can be done in factorial 5 times factorial 5 minus 2, which is factorial 3 divided by factorial 2, and if you calculate this you will get 10, right? There is also a shorter way of doing it. If you want to find 5C2, all you have to do is you have to write numerator 2 times, that is you have to write 2 terms in the numerator because over here it is 2. So you have to write 5 times 4 divided by, this is 2, so you have to write 1 times 2 and you get 10. Okay, so this is the formula for combination. Okay, so now we know, let us consider again. Now we are going to derive one very useful result, which is called that NCR is always equal to n's combination n minus R. Actually this is very reasonable if you think it through. For example, let us consider this example over here. We want to find out in how many ways we can select 2 values out of 5 values. So we write it as 5C2. Now remember, whenever you are selecting 2 values out of here, you are leaving behind 3 values, right? So for every selection of 2 values that you have, you are leaving behind 3 values. So it makes sense that 5C2 should also be equal to 5C3, and this is what it is going to be, but we can prove it mathematically also. What is NCR? NCR is factorial n divided by factorial n minus R divided by factorial R. And if you do this on the right hand side, this is again factorial n, and then it is n minus r, which is going to be factorial r, times divided by factorial n minus r, and you get the same thing, right? So this left hand side and right hand side are same. So this proves that NCR is always going to be equal to NC n minus r. And how is it used? Actually, it is used like this. For example, if somebody asks you to find 10C8, now we know that 10C8 should also be equal to 10C2, right? 10C 10 minus 2, and then it becomes very easy to write. It is simply 10 times 9 divided by 1 times 2, and you get the answer easily. If you write from here, what it means is you have to repeat 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, right? 1 2 3 4 5 6 7 8, and then you have to write it 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, right? And it becomes very cumbersome to write it like this, because in the end we know that this will cancel, 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 and in the end you will be only left with 10 times 9 divided by 1 times 2. So it's better to first convert it to 10C2, which is a smaller number over here, and then evaluate the result, right? Now with these formulas, I think we should be good enough, and we will solve some problems. Okay, so I think you take some time to go through this, and in the next videos we will solve some problems.